Okay, so welcome back. We are now in these next set of videos. What we're going to do is we're going to take a look at how to get the square root of a function. We're going to be given a graph and we have to get the square root of the graph. So this is a little bit different than the previous section where we would have an equation of a radical function that's in transformational form. Okay, so before we were doing things like this. Okay, we were saying like, okay, let's say for example you had something like this. This is an equation in transformational form where you can get a mapping notation, and you would basically take this graph right here and shift it to the left or right, translate it, reflect it, maybe do a stretch on it, and create a new version of that graph. And that's something that we did in the previous section. How this is going to be different for this section is we're going to take a function, like say for example you have a function, let's just say we have this parabola right here. We're going to take a look at what happens if we get the square root of that. We can't get a mapping notation here. It's not in transformational form or anything like that. It's not a translation of that basic square root of x function. It's something entirely different. So we're going to take a look at doing that in this section. Okay, right about now, this is just an introduction to all this. So what we're doing is, before we get to that, I just want to show you a few things about the square root of a number. So I wouldn't even think about this in terms of a graph or anything just yet. Let's just think about numbers in general, just using your calculator to get the square root of a number. And one thing we discussed in the last section was that you cannot get the square root of a negative number. Okay, so if you try to put in square root of -2 in your calculator, it would give you an error message. So we would have no answer for this whatsoever, no answer for this either. We would have to start with 0 and then go into positive numbers. So let's take a look at what we have here. Okay, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. 9 is 3, 16 is 4, and that can continue on to infinity, really. Okay, there's two special numbers in here. Okay, one thing you'll notice is that there are only two numbers that exist in the number system where the square root of the number is the number itself. Okay, square root of 0 is 0, square root of 1 is 1. Okay, so that's going to come up a little bit later, all right? Those are special points known as invariant points. Okay, an invariant point, a definition of invariant point without me actually writing it down, just in general, an invariant point is a point that is the same from the original function as the new function. Okay, so what you're going to have is when you have an original function and then you perform some sort of operation on it to get a new function, these invariant points remain the same, while all the other points will change. Now, you've done invariant points or will do invariant points in 12b as well. Okay, and you're going to have a different set of points for that because it's a different type of graph. Not trying to confuse you with all that. So if you're doing A and B in the same semester, you're going to run into two types of invariant points for two different types of functions. But in 12a, we're sticking with radical functions only. So we have two y values, two values where the square root of the number is itself. And so what we'll say is that square root of 0 is 0 and square root of 1 is 1. So every invariant point will have y values of 0 and 1. Because what we're going to end up doing in the big picture here is we're going to end up getting the square root of y coordinates. So square root of 0 is 0, square root of 1 is 1. We'll see that a little later in the other videos that we're going to do for this section. But for right now, you may just want to hold on to this piece of information. And now let's go back to the table of values that we have here. Okay, what we're doing is we're getting square root of numbers only. And one thing you'll notice is that for most numbers, when you get the square root of it, it becomes a smaller number, right? Square root of 25 is a much smaller number of 5. Square root of 100 is a much smaller number of 10. So when you get the square root of a number, it becomes a lot smaller. So what's going to happen is we're going to keep that in mind when we do graphs in the next video. Like we said, most times the square root of a number is a smaller number. Two exceptions we have are that the square root of a number is the number itself, which is 0 and 1. Something interesting happens between the numbers of 0 and 1. Okay, for those numbers only, the square root of the number is actually larger. So for example, if you take a look at something like this, the square root of 0.25, for example, it's not a smaller number than that. It's actually larger. It's actually 0.5. And the reason for that is you may want to consider that as fractions. Okay, 0.25 is really the square root of 1 over 4, right? 0.25 as a fraction is 1 over 4. And to do a square root of a fraction, you do the square root of the top, square root of 1 is 1, square root of the denominator, 4, is 2, and you can see how that will give you 0.5. So similarly, okay, you can have other values in here, like the square root of 0.49 is actually higher, it's 0.7. So you can see that the numbers between 0 and 1, the square root is larger. 0 and 1 themselves, the square root of those numbers are themselves. And the square root of any number greater than 1 is much smaller, like 4 is 2, 9 is 3. And the square root of any number less than 0, a negative number, doesn't exist at all. So we're going to hold on to all this information a little bit later when we do the next section, which is sketching some graphs.